Happy New Year to all. Today, we discuss a very important topic.
We have the sun right at the center of the solar system, and more than 99% of the mass of the solar system is the sun. And so the sun is responsible for essentially all of the light and the heat and the energy in the solar system, and the sun's gravity is responsible for the motion of all the planets. And so we're very interested in the motion, interested in understanding how the sun works. And so NASA has had a series of spacecraft to go explore the sun, look at the magnetic fields from the sun, look at the particles coming from the sun, look at the evolution of the sun, and so forth. And so the Parker Solar Probe is essentially the most recent major mission that we've sent up to the sun. And the Parker Solar Probe went up a couple of years ago. It's a mission in particular to study the particles that are coming off of the sun and to study the sun's corona, which is its outer edge. And so it's not looking, for instance, at the interior of the sun, or at least not looking directly at the interior, but it is focusing on the corona and the particles which are coming off the sun. Now, this Parker Solar Probe has been up there for a couple of years now, but what it did this in the last week is do it the closest approach that it has ever done to the sun. And it got within, I think it's 6 million kilometers of the sun, which is, well over 90 or 95% of the way to the sun from the Earth. Now, you can't go closer than that because, the closer you go, the harder it is to maintain the health of the spacecraft. Because if you stay there at that close distance, the spacecraft literally is going to melt from the heat and the energy from the sun. And so this was a very fast flyby. And so it went very quickly past the sun at this close distance. But that's going to allow it to do measurements which we would not be able to do from the Earth. We wouldn't be able to do from other satellites, and we wouldn't be able to do from further away. And so it's doing these unique measurements that could not be done by any other mission. Now, we know so far that the Parker Solar Probe successfully completed that mission, the orbit past the sun. We don't have the data down from that yet. I'm not directly involved with the mission. The group that is involved with it is NASA's Heliophysics Division, and the Heliophysics Division at NASA will be providing updates about the Parker Solar Probe and what the mission has discovered during its most recent flyby of the sun.
Yeah, thank you very much. My next question is, Doctor, I would like to know about the opportunities, especially for students studying astronomy. What are the opportunities?
Yeah, so there's many chances to be involved in studying astronomy. First of all, in Sri Lanka, there's some great astronomy programs, for instance, done at the Arthur C. Clarke Center. Has some great astronomy workshops. The University of Colombo has a diploma and certificate programs in astronomy. And so there's many people who've been involved with all of these programs to start to learn astronomy. In degree programs, of course, there's many people studying physics and astronomy in the BSc program at University of Colombo and the other universities across Sri Lanka. So people often ask, how can they work for NASA? There are many opportunities to work for NASA and to be involved in the work that NASA does. Typically, these are here's what I did, and here's what other people can do. I have a BSc in physics, and after I did the BSc in physics, I thought, well, this is, I enjoy what I'm doing. I want to learn more, and so I applied to postgraduate schools. Students from Sri Lanka can apply to many postgraduate programs. In particular, the majority of postgraduate programs are going to be abroad. So there's many programs in the US and in the UK and in Europe and Australia. There's many excellent postgraduate programs. And in these postgraduate programs, you can earn an MSc or a PhD by studying astronomy and by studying physics. These postgraduate programs are highly competitive programs, so you need to be at the top of your class. You need to apply for these programs, but for successful candidates who are accepted into the programs, many of them will pay your way. In other words, you receive a bursary, you receive a tuition waiver to to work toward earning your MSc and your PhD in astronomy or physics. In particular, in the US, many of these programs, you get to, as part of your research, you get to actually work on NASA projects. So that means projects funded by NASA or related to NASA, or looking at NASA data, things like that. So there's NASA involvement in the vast majority of universities across the United States have astronomy programs which are funded in large, which have a great deal of funding and support from NASA. So there's opportunities to work with NASA as a student in many of these postgraduate programs. And there are many students, many international students in these postgraduate programs, including students from Sri Lanka.
Doctor, how to apply to NASA? What are the steps? How to apply?
So for none of these, yes. So the question is how to apply for NASA. These programs that I've mentioned are not at NASA. These are at university. So what you would want to do is continue your studies through the BSc programs in Sri Lanka, and then apply for postgraduate programs at universities across the US or at other universities around the world in the areas that you're most interested in. So you don't apply to NASA. NASA is not a university. You cannot apply to NASA directly. But there's many opportunities to work on NASA-funded and NASA-related research at universities in the US and around the world.
Yeah, thank you very much. Doctor, my next question is, what are the future trends of space explorations? For example, can we find another planet where life can live?
Yeah, so NASA is involved in so many different projects across the solar system. I'm working in the planetary science division at NASA. And so in the planetary science division, we're looking at stuff inside the solar system. We're not looking at black holes. We're not looking at galaxies. We're not looking at other stars for the most part. We're looking at stuff inside our solar system. And one of the big areas that we're interested in inside our solar system is what's called astrobiology or exobiology. And that's essentially the search for life beyond the Earth. We've detected life in many, many environments on the Earth, from deep wells and mines in the Earth to the bottom of the oceans to tops of mountains to very hot areas to very cold areas, kind of all across the Earth in many, many different areas. And now we're starting to look for life elsewhere in the universe and elsewhere in the solar system. Now we have never found anything. We've never found any life on Mars. We've never found any viruses on asteroids. We've never found any bacteria in comets. And we keep looking. We think that there is probably, statistically speaking, there's probably life somewhere else in the universe, but we've never found it. What we are doing right now is we have robotic spacecraft which will be visiting a number of different places in the solar system. One of them is Mars, to continue our exploration at Mars. Mars is pretty dry right now. There's not a lot of liquid water on the surface, even though there used to be billions of years ago. But it could be that there's fossilized bacteria, for instance, below the surface on Mars. That would be really interesting to find if we found it, because that would be evidence of the habitability and, in fact, perhaps past evidence of past life on Mars. Enceladus is a moon of Saturn that has warm oceans on it. Europa is a moon of Jupiter that has warm oceans on it. In fact, we have a couple of spacecraft which are on their way to Europa right now. One is called JUICE, which is the Jupiter Icy Moons Explorer. It's a collaboration between ESA, which is the European Space Agency, and NASA. And then there's a NASA mission called Europa Clipper. And both these are headed up to the Jupiter and Europa system right now. And they're going to be getting there in a couple of years and really probing around and seeing what they can find from in orbit around the system. We also have the Dragonfly mission, which is a NASA mission, and it's going to be launching in a couple of years in 2028. It's going to go up to Saturn's moon, Titan, and it's going to it's essentially a drone, an octocopter, and so it's going to use its propellers and be able to land on the surface in one location and then fly from one location to another location to another location along the surface of Europa. Of Titan. And Titan is a very Earth-like environment. It's got hills and mountains and rainstorms and oceans and all of this stuff there. So it's pretty similar to the Earth. Only difference is it's really, really cold. And so In fact, it's well below the freezing temperature of water. And so the liquid is not water, but it's hydrocarbons, meaning methane and ethane. And so, so any life or biotic or prebiotic material there is going to be very different than what we find on Earth. But it's got a lot of exciting chemistry there. And so Titan, as to be explored by the Dragonfly mission, is certainly, a real highlight of the sorts of things that we're starting to explore in terms of astrobiology in the solar system.
Yeah, thank you, Doctor. As a scientist, what's your opinion about Sri Lanka for the astronomy?
I think that Sri Lanka has some fantastic astronomers who have come from here, and the capability of the country. There's so many highly motivated students in the country. It's really exciting to see all the interest in astronomy and all the interest in research that's going on here. So there's some excellent students. There's some excellent ideas for research that can happen here, and it's exciting being here and seeing everything which is going on in the country. So it's a great country with great opportunities for doing science and doing research in astronomy and so many other fields.
Yeah, thank you so much, Doctor. Today we discussed with Dr. Henry Throop. Thank you so much for sharing your knowledge and your experiences with us. Thank you very much.
Thank you.